this information. So we're going to learn about linear functions or nonlinear functions. So we're continuing in the functions world. And I would remember that when you substitute, you need to use parentheses. So when you substitute, I would encourage you to remember to use parentheses. Just because it lessens the chances of us making a mistake. Now let's go back, it's been the weekend, and review just a little bit. So when we talk about functions, sometimes they're ordered pairs, they're called relations, where all x values have one y value, meaning the x values don't repeat. The x's are sometimes called domain, the y values are sometimes called ranges. And then we went through this whole thing of identifying, is it yes a function or no not a function? And that's when we look at that domain, the x value, and we see does it repeat. We also talked about how the equation must have an x and a y, or just a y. Exponents must only touch the x for it to be a function. We talked about the vertical line test, where you drag your pen or pencil over it and you say, no, that was not a function. Yes, that was a function. No, that was not a function, right? We've talked about comparing linear functions, and linear means on a line. And so we compared their slopes, right? And we took their slopes and then we converted them into negative and positive value or decimals. So now we're talking about linear, meaning it makes a line, or nonlinear, but they're still going to be functions. So we're going to be able to identify linear functions from nonlinear functions. So here we go. Grab your calculators. And we're going to fill in this table and then we're going to graph it. So instead of the x value, I'm going to substitute up here -2. So my problem says x squared plus 1. So I'm going to do -2 squared plus 1. I'm using my parentheses, especially when there are negatives and I'm substituting. What do you get as your answer? 5. We're going to continue. -1 goes in for x. So -1 squared plus 1 is 2. Zero squared plus 1 . Alex, stop. 1 squared plus 1 is 2. And 2 squared plus 1 is 5. I filled in my table. Now I'm going to graph it. -2, 5. You should be graphing along with me. -1, 2. 0, 1. 1, 2. And 2, 5. Is it a function? Yeah, it's a function. Can you do the vertical line test? Yeah. It's a function. If I go across it vertically, I only hit one dot at a time, one ordered pair at a time. Yes, it's a function. Is it linear? No, it is not linear. The thing that makes it not linear is that there's an exponent. You can have an exponent and still be a function. That's fine. As long as the exponent only touches the x variable. But you cannot be linear and have an exponent. So make sure you have that written down. Let's try the next one. Fill in the table. Y equals 1/2 x. Y equals 1/2 x. We're filling in the table. Grab your calculator. 1/2 times -4. What do you get? 1/2 times -4. What do you get? -2. You could divide by 2. It's the same thing as multiplying by 1/2. 1/2 times -2, or -2 divided by 2. What do you get? -1. 1/2 times 0. Why do I not even need to put this in my calculator? Why is there no need? Anything times 0 is 0. What if it said +4? Right? You have to be aware. Don't just know that 0 is always 0. That's not true. Oh, 1/2 times 2 is 1. And 1/2 times 4 is, oops, that says 12. 1/2 times 4 is 2. All right, let's graph it. -4, -2. -2, -1. 0, 0. 2, 1. 4, 2. Is it? Yes. And you guys, this is a line because it's in y equals mx plus b. M is your slope, correct? What's the slope of this line? 1/2. B is your y-intercept. When x is 0, what's your y value? Yeah, it says +0 on the end. What's the same about these two functions? What's the same in this guy? Look at it. Raise your hand when you have an answer. What's the same over here and over here? What's the same? Raise your hand when you have an answer. What's the same in this? Raise your hand when you have an answer. What's the same in this equation and this equation? Isabella, what's one thing that's the same? Yeah, they both start with y equals. That's the same. What else is the same? Nico, what's the same? They both have the number 1 in them? What else is the same, Alex? They both have x. They're going to have an input, a number you put into the problem, an x, and an output, a number that comes out, the answer. What's different about them? One has an exponent and one has a fraction. So, what do we notice that's different about the functions? One has an exponent, right? What's the same? They both have y equals, yes? And they both have an x value. right? Those are the same. So let's talk about linear versus nonlinear. Let's fill in these notes over here. Linear functions. A linear function has a graph that makes a line. A linear function has a graph that makes a line. Linear equations are in the form y equals mx plus b. What does m equal? Slope. And what does b equal? Y-intercept. Good. If you're given a table of values, right, a table of values, you need to make sure the change in y over the change in x is always constant. You need to make sure the change in y and the change in x are always constant. All right, like from here is from 3 to 4 is 1. Yes? This is on page 33 of our notebooks. But what's here? That's 2. Is that constant? Because here it's back to 1. But if I go over here, what do you do to 22 to get 27? Plus 5. What about here? Plus 10. What about here? Plus 5. Is this constant? What's the change in y over change in x for this guy? 1/5. What's this one? 2 over 10. And what's this one? Are those all three the same fraction? I can simplify 2 over 10. What does it become? 1/5. Are they all the same? So you need to make sure it's always constant. Check them all. It's just adding or subtracting. Tanner, why don't you come sit at the end of your row, please? What do you think a nonlinear function looks like on a graph? Yeah, it doesn't make a line. Into your row. Has a graph that doesn't make a line. It's still a function. It still passes the vertical test. Vertical line test is okay, right? It still passes the vertical line test. It's still a function. It's still a function. It's just not a linear function. That's okay. Tell me about our ladies. Tell me about our graph that was not a function. Well, think about it. Look at the graph. Look at the equation. That is not a function, not a linear function. Look over here. What did you know? What did you notice about that equation? Raise your hand. What's different? What was one of the differences we talked about? This one's linear. This one's not. Raise your hand. Gage, what does the nonlinear function have? It has exponents. So when we're looking at it, you're looking, the identifier is the exponents. And remember, it has to be on the x. What if there's an exponent on the y? It's not a function. This is a function. So there might be an exponent on the x. The other thing that we might need to look for is a variable x in the denominator. That's not how you spell it. denominator. A variable in the denominator. All right, I'm going to show you. Graphing calculator, are you ready? All right, so this problem is going to be 5x minus 8. And I'm going to graph it. I'm just showing you. Tell me, linear or nonlinear? Linear. Because 5x minus 8. 5x minus 8 is linear. If I did x squared plus 5, is it going to be linear or nonlinear? Nonlinear. Why? There's an exponent. Let's see it. Takes a minute. If I do 0.7 minus 5x, linear or nonlinear? It's linear. What's the coefficient of x? Negative 5. What's the lonely number? What's the constant? 0.7. Linear. What if I did x to the power of 3 minus 8? Nonlinear. Why? Because there's an exponent. What if I did 12 divided by x? 12 divided by x. Look at your notes.
That's linear. Oh my god, what?
That's nonlinear. And why is it nonlinear? Look at your nonlinear notes. Division is not written anywhere in your notes. Look at your notes. You literally it's the last thing you wrote on your paper.
Oh, there's only a variable.
No, it's the last thing you wrote on your paper.
Variable in the denominator.
There's a variable in the denominator. The x is in the denominator.
Yeah.
If you have an x in your denominator, linear or nonlinear?
That's linear. That is linear.
It is linear.
It's more linear than a linear.
Linear. A linear equation is in the form y equals mx plus b. There's a y, there's an x, and there are two values, a slope and an intercept. Nonlinear has exponents on the x, or the variable x is in the denominator. It's right here in your notes. If you're given a table, if you're given a table of values, you need to find the change in y and change in x every single time and make sure it's even. 1 over 5, 2 over 10, 1 over 5, that's okay because 1/5 and 2/10 are the same. Linear or nonlinear? How do you know it's not a function? Someone give me one example that would say automatically, no, that's not a function. You could turn back in your notes to page 53. How would you say automatically, no, that's not a function? You could turn back in your notes to page 53. '53 is where you're going to find the information on not a function. Or, what's one thing? If your x repeats, if your x value repeats more than once, it's not a function. If you have the same x number twice. Down here, how are you going to know when given an equation it's not a function? How are you going to know? Look at these examples that say yes and no. What tells you no, it's not even a function? Nathan. An exponent on the y, not a function. What else? Yeah, there's not a y at all. If there's just the variable x, not a function. It's linear.